Hello everybody, this is Dr. Christopher White, and today we are going to be looking at assignment number 4, which is also exercise number 4 from Ritter and Peterson. Okay, so we're going to turn to page, should have had the page number written down, that would have been very smart of me, wouldn't it? We're going to turn to page number, wait for it, 41. So exercise number 4 starts on page 41. You can see it's titled Depositional Environments, and you can see obviously we have the purple square here giving us the learning objectives for this exercise. So at the bottom of page 41 you can see we have a bit of text which is telling us about what the lab is going to be about. So you can read that, and then as we turn here onto page 42 you can see we have a diagram showing us some of the basic environment of deposition, and then again it's also going to follow this on with another discussion of depositional environments and a diagram that connects with that text. Okay, once again, just like the other exercises, please read the text. It helps you, so don't just ignore it. Now on page 43, now it's not going to fit all on all the oh no, it will fit, hooray. Okay, on page 43 you can see we have this table. Now this table is split into continental, transitional and marine, and you can see there are several environments listed, and you can see for each environment there's an environmental process, a texture, organisms, sedimentary structures and sedimentary rocks. And so for each of these environments, let's look at alluvial fan for instance. So it's going to tell us what kind of process actually forms these rocks. Alright, so it's telling us things like they're formed in flash floods, they can be related to debris flows, these are high energy events, and there's oxidation involved. So obviously, as we know these are high energy events, we can obviously expect quite large clasts, and as there's oxidation involved, well, that might mean the rock could be a rusty colour. Texture, poorly sorted, variable rounding. So obviously this would mean it would have a sediment that contains lots of different class sizes, and those class sizes could be anywhere from very angular to rather round. Organisms, maybe there could be some land plants and animals incorporated into the sediment, which we would see as fossils. Sedimentary structures, inclined bedding planes. That means the bedding, which in most cases would normally be horizontal, is actually dipping, so it's at an angle. They also say there could be channels in there. So a channel essentially is a linear structure through which something is moving. The normal version of a channel would be something like a river. But obviously channels can also be exploited by other things such as mass flows. So if there's some kind of landslide, well, that can also form its own channel. And then the rock types themselves associated with this type of deposit are rocks like conglomerates, breccias, and they will typically have a red colour, which relates back to the oxidation back here. So for each of these rocks, there's a very detailed description about, once again, the environmental process, the textures, the organisms, the sedimentary structures, and the types of sedimentary rocks associated with them. Now, this table is going to be what you base your answers to exercise number 4 on, okay? So essentially this table is it in terms of answering the question. So all the information you need is going to be on the following pages and this table right here. Okay, so on page 44 and page 45 we have several pictures. So for instance, here's actually an alluvial fan deposit, a picture of one, and a picture of what an alluvial fan sediment looks like. Obviously then we have a glacier, what glacial sediments look like, essentially river sediments and what river sediments look like, desert environment, what desert sediments look like, or rocks formed from desert sediment, should I say. Onto page 46, we have a swamp environment and what swamp-based sediments look like. We have a beach environment and a picture of what beach sediments look like. Now, these pictures are going to be helpful. They'll help to suggest possible environments. We'll see that in a second. We have essentially a ooidal shoal, so essentially an ooid-based sediment, and this is what they look like. And then obviously how we have a reef-based sediment and what reef-based limestones look like. So it's giving you these pictures not just to show you them, but it's giving you them as a possible helping tool for the next few questions. Okay, so exercise 48 is parts A, B, C, D, E, and F. We're doing the lot. Okay, so we will be doing every exercise in, sorry, we're doing every part of exercise 4. Okay, so here we go, page 48. So what you can see is for each part, we're going to have pictures of the rock, so it kind of gives you a picture showing you their context in the outcrop. It gives you a closer picture, and it gives you a very close-up picture. All right, so you have visual evidence, but also in a yellow box associated with the pictures, you're going to have a description of the rock itself. So for this first one, we have a conglomerate with interbeds of sandstone. Composition: boulders, cobbles, and pebbles comprised of sand and limestone. Matrix composed of quartz, lithics, and mud. Lithics means pieces of rock. Texture: poorly sorted, large sub-rounded clasts. Colour: red to reddish brown. That's the oxidation that we touched on earlier. Sedimentary structures: thick beds with primary dips of a few degrees to the east. So the beds aren't horizontal. So the beds aren't nice and horizontal. They're slightly angled, so they're dipping by a few degrees. And we also see gravel-filled channels. There are no fossils, and the regional trend, that's not so important to us right now. So you can see what we have here is a very big, very coarse rock. It has a red colour to it. It doesn't have any fossils, and you can see it's very poorly sorted. You have a big range of clast sizes here, you know, and the clasts themselves tend to be rather angular. We have some sharpish looking corners there. By the way, if you want to review things like rounding and sorting and class size, I would advise you go back to your physical geology notes and have a look at the sedimentary rock lectures, and you'll find a discussion in there about, you know, what variations in rounding, what variations in class size, and what variations in the sorting actually mean. Okay, so we have all this information. So what we can do then is we can refer back to our table on page 43. So let's do that. So okay, so we're going to ignore environmental processes, because at the moment that's not really going to help us very much. Okay, so the first thing we're going to look at is we're going to have a think about, well, the easiest thing to do is to look at the types of rock. Okay, so if we go back to page, now I'm sorry this is going to be sideways, but if we go back to page 48, you will see the first thing it makes very clear is we have a conglomerate. All right, now conglomerates, as you know, are quite coarse clastic sedimentary rocks. So the first thing we should do is just have a look at the rocks associated with each of these environments of deposition and see, right, where are the conglomerates? Okay, so we have conglomerate here associated with alluvial fans, conglomerate here associated with glaciers. Nope, not lake sediments. Possible conglomerate there, meandering streams. No conglomerate there, so not desert. No conglomerate here, not playa. Okay, pebble conglomerate pops up here, possibly beach. Possible conglomerate turns up here, deltas. Tidal flats, conglomerate. Whoa, conglomerates everywhere, isn't it? Marine, nope. Reef, nope. Deep marine, nope. So we have conglomerates here, 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 and here. So straight away we've instantly gotten rid of a whole load of rocks. Sorry, a whole load of depositional environments. Now the one thing that we should also point out is when it's discussing this particular environment, it's pretty much dominated by conglomerate. So normally when you're looking at these descriptions here, typically the most important rocks will be first. So okay, so number one, the fact that conglomerate turns up first here for alluvial fans suggests that it should be an environment that produces a lot of conglomerate. In terms of glaciers, conglomerate turns up first, so once again it should be an environment that produces a lot of conglomerate. In terms of meandering rivers, well, that's second in the list, so we should expect the possibility of quite a lot of conglomerate there. Now obviously these two, no conglomerate. In the case of beach environments, deltas and barrier islands, and tidal flats, please note the conglomerate is all the way down at the bottom. So these environments are less likely to produce conglomerates. So that should be a little hint as to whether they are, likely environments. So what other things did we see? Well, you also notice in the description, it quite clearly said there were no fossils. All right, so we have our environments that have conglomerates associated with them. Let's look and see whether we would expect to see fossils. Okay, number one, alluvial fans, sparse land plants and animals. So there is the possibility of fossils, but the chance is relatively low. I mean, it says sparse right there. Glacial sediments, few. So chance of finding fossils in these sediments, relatively low. River sediments, okay, here we go. Vertebrates, essentially we're looking at things like dinosaurs and mammals. We would expect to find fossils in these kinds of sediments. Well, we found no fossils whatsoever in the rock, so that suggests that this environment is far less likely now. As we head down here into the transitional environments, we would expect to find beach invertebrates, so bits of broken shell in a beach environment. We would expect to find in a delta and barrier island, we expect to find lots of marine invertebrates, some root casts, and lots of trace fossils. So once again, this should be a very fossil-rich rock. And in terms of tidal flats, we should expect to find lots of mollusk fossils, so lots of marine invertebrate fossils, some algae fossils, and maybe some stromatolites. So once again, probably quite a fossil-rich rock. So the fact that we found no fossils in the rock from Part A suggests that these environments, probably not the environment. That, combined with the fact that they're highly unlikely to produce conglomerate in large quantities, means that no, these probably aren't the environments we're looking at in Part A. So the environments we're probably looking at are going to be either a glacial environment or an alluvial fan environment. Those are our two most likely culprits. So, okay, is there anything else that we can look at? Well, in the text it says that the sediment is poorly sorted, and we can see in both alluvial fan and glacial sediments, they are both poorly sorted, so that's not really going to do very much for us. Now, there is one final thing we haven't looked at, which is sedimentary structures. In a glacial sediment, you will notice sedimentary structures are few, because when a glacier deposits a sediment, it literally just dumps the sediment. It just drops it. So it's just essentially a big pile of sediment which is completely unorganized. In contrast, when we look at alluvial fan structures, we can see inclined bedding. So remember, that means most sedimentary structures will give us nice horizontal bedding like this. However, in the case of alluvial fans, the bedding is naturally tilted. It's dipping. All right. So what we need to do is we need to see, can we see anything that's similar to this? We might also have channel deposits. So let's go back to Part A. Let's look in our description. So, okay, conglomerate, yes, obviously this describes essentially what the conglomerate's made from. That's not really that helpful to us. Poorly sorted, we know that already. Reddish colour, well, that's also kind of known already. Okay, here we go. Thick bedded with primary dips of a few degrees to the east. It's not nice and horizontally bedded. It's dipping slightly. The beds are at an angle, and they're dipping, a few degrees to the east. So east would be that way. Okay, now that's very helpful to us, isn't it? Now then, of course, we have the final thing, as we've discussed. You can obviously see this rusty colour. It's very obvious in the picture. And of course, that ties back nicely with the fact that right here it says oxidation. So there we go. So I think it's pretty obvious that the rock in Part A is a alluvial fan sediment. Okay, so the other thing we can do is, if we actually have a look at the pictures are here to help us. So if we actually find the alluvial fan picture, which is on page 44, you can see, right, here's an alluvial fan, here's a modern alluvial fan sediment, and you'll notice it is strikingly similar to the picture we have in Part A. So that's another way that we can kind of, get a bit of a hint about whether it's going to be alluvial fan or glacial. So this is what a glacial sediment looks like. Lots and lots of very, very fine-grained matrix with a few large clasts distributed around. Okay, so In terms of part A, obviously then gives us 3 questions to answer. So, what is the dominant sedimentary rock type? It's going to be in the description here. Remember, the rock that comes first is going to be the dominant rock type. Next, what does the red colour suggest about the environment of deposition? Well, once again, if you go back and you have a quick read through your physical geology sedimentary rock notes, you will know that a red colour is typically associated with arid or semi-arid environments, so desert or semi-desert environments. Not always 100% accurate, but most of the time, if you see a rock with this kind of rusty red colour, it's going to mean you're in a desert or semi-desert environment. And finally, part 3. Let's see. They are most likely deposited in which sedimentary environment, and then explain your answer. So don't just say alluvial fan. You need a little explanation as to why you went for alluvial fan. So, it's made of conglomerate. It has this rusty red colour. You have dipping beds. It has very few fossils. So I want that evidence as well, please. Don't just say alluvial fan, then just leave it there, because that's, you're going to be losing marks. So if we move on to part B, you can see there are no pictures here. That's because they are all on the next page. All right. So you can see for part B, you can see whatever rock we have. It's very fossil rich, which is always good to see. You can see in this case it's sandstones interbedded with siltstones. In terms of textures and colour, well, we have moderate, well-sorted, sub-rounded grains. It's kind of like tan or grey in colour, so we can see there's a bit of variation in rock type, can't we? You can see we have these slightly more tan-coloured rocks and these slightly grey-coloured rocks. And you can also see from the picture at the top here, well, we have ourselves a couple of coal seams, don't we? Okay, that could be an interesting thing to note later on. It could be important to answering what type of environment this deposit was formed in. So we have lots of freshwater plants, dinosaur footprints and root molds. All right. And it consists of sand-filled channels. Essentially, that means that you have these channel fills, so there'll be these semicircular structures. So you'll have a structure that kind of dips down and comes around like a U. Okay, that's like a channel. If you take a slice for a river, that's the kind of shape you would see. And within that channel, you would find essentially these sands and some silts. So, once again, so first of all, what is the dominant sedimentary rock type shown in figure 4.8? So once again, here's figure 4.8. So it does tell you the answer down here straight away. It's sandstone. Now we can also see that just by looking at the pictures, because if we look at the pictures here, we can see we have lots of this rather chunky tan coloured rock with a few of these darker layers in between. So the darker layer is obviously going to be the siltstone, because any rock that's typically made of silt or clay sized particles will normally have quite a medium to dark grey colour. In contrast, sandstones by their nature can range anywhere in colour from kind of almost white to kind of a yellowish cream to a kind of slightly deeper, more tan colour, all the way to a rusty red colour if they formed in a desert environment. So there's lots of colour variation in sandstones, but the tan colour that these rocks have would suggest something likely a sandstone. And you can see from this wider shot up here, you can see it makes up the vast majority of the sequence. Okay, so question 2: what economically important sedimentary rock occurs in this outcrop? Well, if we just go back, well, let's have a think about it. Is sandstone economically important? Not really. You can use it as building stone, but it's not that important in the grand scale of things. The siltstone, is that important? Well, no. Siltstone's everywhere. Not economically important in the slightest. But oh look, in the top picture here, they just happen to have labelled 2 seams of coal. And although not as economically important as it once was, coal is still an economically important rock. So that might give you a hint about what the answer to that one is. And finally, part 3, rocks of the Black Hawk were most likely deposited in which of the sedimentary environments listed in table 4.1? Once again, explain your answer. So I'm not going to help you with this. You're going to look at the evidence from the pictures and from the description down here. You're going to go back to table 4.1 and you are going to come up with your answer, and you're going to explain your answer as well, please. Okay. On to part C. So part C is a Cedar Mountain formation. So once again, you've got to turn to the next page for it. All right. Now, I need to point out something actually. We can just go back for a second. This picture here, picture C, is going to be quite important. I want you to note, please, that the sandstone, which is written in white here, occurs in this feature here. Notice that this feature comes around here, comes up, comes down, comes along, comes up here, comes up, comes around there, and then comes around there like that, okay? So please notice that that feature has this very long linear shape to it, okay? It's like a piece of cooked spaghetti almost, isn't it? So question 1, what two sedimentary rock types predominate in this formation? Well, once again, we can see here we have a pebbly conglomerate and sandstone, all right, encased in siltstone and shale. So this one is a little bit more difficult to work out what the dominant rock types are. Well, because you would assume the dominant rock type should be pebble conglomerate and sandstone. However, if we look at picture C here, we can see actually we have the sandstone. The sandstone and pebble conglomerate are only found in this little thing here. In contrast, the shale, you can see it labelled right here, covers this whole area here and here. So the predominant rock types are going to be whatever's in the channel, which seems to be mostly pebbly conglomerate based on this picture here, and the shales, the siltstones, the mudstones, either side. So that one's a slightly more difficult question. I just figured it was only fair to point that one out to you. So how do we describe the shape of the sandstone body shown in the satellite image 4.9c? Well, we've already gone and discussed how the sandstone is occurring in this linear wiggly body here. And you have to think to yourself, what kind of feature that occurs on the modern surface of the Earth forms this kind of single linear wiggly feature? And so you're going to have to take a few minutes and think about that one yourself. Okay. So once again, environment of deposition, explain your answers. All right. Finally, number 4, explain why dinosaur skeletons collected from shales at locality 1 on figure 4.9a. So let's go and look at locality 1. Here we go. Here it is. There's locality 1 right at the bottom of the sequence here. And there's 2. Okay. Are more likely to be complete than dinosaur remains collected from the sandstone at locality 2. Okay. Should I say collected from sandstones at locality 2. So we need to have a look in here. Okay, so I'm just going to stick my head in there for a second just to have a better look. Do you know what? Let's all zoom in. We're going to see just how good the camera is. Okay, the camera arm is fighting me. Okay, now I'm going to manually focus, so please just give me 1 second just to see if I can sharpen up the image. Okay, here we go. Wonderful. There we are. So what we can see is we can see why are dinosaur fossils from this material here, all right, in better condition than this material here. Now I'm just going to open up my other book for a second because I just want to check the wording of the question, but I don't want to zoom out. So I just want to be sure when I make my answer, or when I hopefully point you towards the answer. Okay, good. So location 1 are shales, they are mudstones. Location 2 is the sandstone. So if we just come back here and look at picture C, well, where's the sandstone located? All right. Well, the sandstone's in this long linear feature here. The shale is either side of it. So if you manage to correctly work out what feature is producing this long linear body here, full of sandstone and conglomerate, you should be able to work out that this is not a nice low energy environment. It's more moderate in energy. So any dinosaur skeleton that falls into a moderate energy environment, well, it's going to be buffeted about, isn't it? In contrast, rock number 1, which is a shale, well, that's going to be deposited on the plains either side of this feature. And the sediment deposited in these areas will be deposited when the feature, well, I'm not going to tell you because it would give it away, unfortunately. Sorry, guys. But suffice to say, these environments either side are far more low energy, far more peaceful, and so any carcass, any skeleton that's deposited in these areas here are far more likely to be, well, far more less likely to be damaged, should I say. So what we have here is a situation of once you work out what this is, okay, and you realize that this is full of sandstones and conglomerates, this is full of mudstones either side, that's going to tell you essentially why the sandstones at location 2 are more likely to give you broken up and damaged dinosaur fossils, or dinosaur skeletons should I say, whereas the shales from location number 1, which would be in these locations here and here, okay, are far more likely to give you dinosaur skeletons which are in much better conditions. So I'm afraid I really can't help you more than that, but I'm sure you can crack it. I believe in you guys. Okay, so I'm just going to pull the camera up slightly more. Okay, let's go back. Here we go. So guys, just for time for a quick refocus, I'm afraid I need to do this manually. All right, it's probably the best it's going to get. Okay, so on to part D. This is the marker shale. All right, I've got to be honest, part D is a pretty straightforward one, so I'm not really going to go into it. I think you can crack part D by yourselves. Part E, the Monkey Pie Formation. All right, so that's these pictures here. All right. Now, I do want you to take notice of the fact that we do have a lot of stuff going on here, don't we? Okay, you can see we have horizontally bedded rocks here, but we can see within some of these horizontally bedded rocks we have these features here. Okay, so now they're a bit difficult to see, but you can just about see them. Good. But do you know what? I'm just going to zoom the camera in. Let's now I know I have the power. Let's use it. Let's just try and steady that. I do apologize for the bouncing there. You can quite clearly see we do have these diagonal features cutting across the rock. Okay, so now these diagonal features are quite important because I'm sure some of you will remember from doing sedimentary rocks in physical geology. Sorry, I'm just going to reset my camera a little bit, try and improve the image. There we go. That these things are called, where are we? Well, these things are referred to as cross beds, but they're also referred to as cross-laminated. Okay, so these are like very, very small cross beds. And cross beds are produced by the transportation or movement of things like dunes or slightly smaller features like large ripples. All right. Now, there's also other things to note. Look at this. Here we have a muddy sediment here, and it has these cracks in the top of it. All right. So we're probably quite familiar with these in the Houston area. Okay. These are, of course, mud cracks. And also, please note, you have multiple reptile trackways and swim tracks. So multiple trackways suggest dry land. Swim tracks suggest that, well, as the animals moving through this environment of deposition, it's essentially swimming. So clearly we have an environment that has both dry and wet portions. Okay, so just bear that in mind. So this one is going to be a little bit more complex. Okay, but so you're really going to have a good think about your answers for part E. It's rather a challenging one. All right. So once again, I'm not going to go into great detail. I think you can probably crack part E by yourselves. Once again, though, if you do have difficulty with it, we can discuss it during office hours at the allotted time and day. And then finally, part F here. So what do the cross-bedding presence? Well, let's try that one again, shall we? What do the cross-bedding presence of crinoids and oolitic nature of the limestones indicate about the environment of deposition. Okay, well, there you go. Here's the situation. Now, once again, we have these oolitic limestones. You can see these are the ooids. Now, straight away, we should be able to work this one out relatively easily. Well, the fact we have cross-bedding obviously tells us we have... Oh, the fact we have cross-bedding, sorry, there's the question there. Obviously tells us we have dunes or relatively large ripples moving around. All right. The presence of crinoids. Well, crinoids are a marine fossil. If you want to know what a crinoid looks like, just go onto Google and Google crinoids. They're still around now. They're quite interesting creatures. They're actually related to animals like sea urchins and starfish. And then the final thing is, of course, we have the ooids. Now, this question is actually answered because they gave us a very, very helpful photograph early on. So if we just go back here and we come to page 47, we're going to see this picture here, and here we go. So here's a nice picture of a oolitic rock. These are the ooids here. And, oh, will you look at that? They've given us a nice picture of the kind of environment in which you would expect to find ooids. All right, look at that, shallow, warm, clear water, normal salinity, and you can probably work out the rest for yourself because they've been so wonderfully nice to give us pretty much the answer that we require. And that's really it for exercise number 4. As you can see, it's a relatively straightforward exercise, and you just always need to remember, if I can find the right page, I do apologise. There we go. You always need to remember that the table on page 43 is the important bit to answering this lab, okay? Because all of the parts, all the descriptions they give you can be essentially transferred back to this table, and you can find the answer using this table, okay? So it's all here. This is going to answer the lab for you as long as you use it. If you don't use it, well, it's probably not going to go too well for you. So use the tools which you have been given. All right, everyone. So that's it for assignment number 4. I'm sure you'll be able to do very, very well with it. Have yourselves a good day.